So we made this chart, and we're trying to figure out a formula that relates P and Q. And hopefully we've taken enough algebra that we recognize that this is a linear function, that the steady change between the increase in the P and the increase in the Q, like every one of these causes some of these or whatever. And this is linear, and we can write down a linear function, and it's going to be y equals, if we're using point slope, it's y value plus slope x minus x value, except they're not y and x. We'll make that q, and we'll make that p, and this is a y value. I need to pick a line on the chart. I'll pick this one. Our q value will be 300, and the corresponding x value for that will be 80, and we need the slope. It's the difference of the y's over difference of the x's. Except that means difference of the q's over the difference of the p's. So that means 20, this is going up by 20, and this is going down by 5, so 20 over negative 5 is negative 4. So we can write an equation that q equals 300 minus 4 times p minus 80, and then I guess I want to simplify that. So that's 300 minus 4p plus 320, so that's q equals 620 minus 4p. Hey, we got our formula for q. What's the relationship between price and quantity? Here's the relationship between price and quantity. We've answered part 1 of the question. To answer part 2, I want to write down a formula for R of q. And here's the place where we realize, oh no, we did part 1 wrong, because I always screw this up the first time. So how did we screw this up? If I want a formula for R of q, it's going to be p times q. I want q to be the variable that's left alone, so I need to change p. I need what's p of q, and I need to multiply that by q. But I don't have p of q. I have q of p. I solved this equation the wrong way around. I guess the mistake I made was at the beginning. When I put the p's on the left and q's on the right, I should have made the q's the x guys and the p's the y guys. But that is not a big deal. It's okay. We can fix that. How do we fix that? I take the equation q equals 620 minus 4p, and we solve for p. And that'll get p of q instead of q of p. So I guess I add 4p to both sides. I guess I'll subtract q from both sides, so I get 4p equals 620 minus q, divide both sides by 4. We could make this one big fraction on the right, but life will be better if we have it separate. That gives me 1, 22, 5 times 25 times 155 minus 1/4 q. Here's our formula for p. And now the same formula that r equals p times q means a different thing now. P becomes this thing, so I get that times q. 155 minus 1/4 q. I can leave it like this. This is a formula, but I'm going to need to take a derivative. Life will be easier if I distribute. I'd rather use the power rule than the product rule. I get 155q minus 1/4 q squared. There's r of q. And then what are we supposed to do? We're supposed to maximize it. I want to maximize this. A thing worth noting, when we did these optimization problems before spring break, I made a big deal about thinking about the domain. By and large, we don't think too much about the domain in these contexts. It is true that if I graphed that formula for the price and quantity, like the demand curve, becomes negative at a point and the problem stops making sense. So really I should cut it off there. But when the price or quantity goes negative, that means the revenue also goes negative. So that's not going to turn out to be the maximum. Cutting it off would give us the closed interval thing, but dealing with the closed interval thing is usually not worth the effort that it takes to figure out what is the correct domain. So I'm going to usually solve this on the interval from 0 to infinity. Closed or open at 0, I don't care usually. Closed if you can. We're not going to try and use the closed interval trick. What's the derivative of r? R prime of q is 155 minus 2 times 1/4 is 1/2 q. Hey, I'm going to use the second derivative trick because it's the best one. The second derivative is negative 1/2. Hey, the second derivative is always negative. So any critical point is the global max. I guess I could have also gotten this by saying, hey, this formula is a parabola that opens downwards, so it has a global max. That's another way to just instantly know there is a global max. How do I find my critical point? I said r prime equals 0. So 155 minus 1/2 q equals 0. So 155 equals 1/2 q, so q is 310. That's the q value that maximizes revenue. Now's the part where we go back and say, what were they actually asking? They just said maximize it. They said show it's the maximum. The line show it's the maximum is saying, hey, include that sentence. Maximize it, to me, sounds like, hey, we should probably say what the maximum revenue is. Like, and even if I don't do that, I should say what the price is. Like, giving the instructions to the guy on the boat that, hey, you should let 310 people on. Well, that's not helpful. He needs to know what number to put on the sign for the price. Like, that's the thing that he uses to start his process of getting the maximum revenue. So we should probably find out what the price that goes with it. How do I find the price? I found a formula for the price a second ago. Price is 155 minus 1/4 q. And the q that will give us the maximum is 310. So I want, hey, what's 155 minus 1/4 of 310? Hey, I typed it in a second ago. It's 77.5. The price that will maximize revenue is 77.5. So revenue is maximized at a price of $77.50, giving sales of 310. Tours, I guess, were the things we were selling, yielding revenue of whatever is 77.50 times 310 is. Hey, I multiplied it, it's 24,025. There we go. That's our maximum revenue. Cool. A thing worth noticing is that we had that bad... When we screwed this up the first time, we had q as a function of p, and from there we could have found revenue as a function of p. Revenue as a function of p would have been q times p, same formula. Would be that thing times p. That's going to give us the same maximum. Like, the revenue is the same thing of a different input. The maximum it's going to give us is at p equals 77.5, the same p-value we found before, and the maximum value of that function is still going to be 24,025. So the function works that way. The only reason we had to do it the other way is they told us, hey, find r as a function of q. So we had to get the other thing written down, even if we solved the problem from this version.